Welcome to Sendiness channel and welcome to class. Today we are taking on Venn diagram, the Venn diagram. When we talk of Venn diagram, what is Venn diagram about? With the Venn diagram, it is the representation of sets in a diagram. Okay, so we already know what sets are from our previous lesson. So how do we represent sets in a Venn diagram? It is the use of what diagrams such as the rectangle, the square, and then the triangle. So in this form, so let's say we have set A as 1, 2, 3, 4, and 5. And then let's say set B, we have 2, 4, 6, 8, and then 10. Okay, so we want to represent this set in a Venn diagram using a diagram, right? So let's represent A using a diagram, let's say a circle. So this is a circle, that is a set A. And then we list the elements in the circle. So we have 1, 2, 3, 4, 5. Okay, so that is how we represent set A in a diagram, which is the circle. Now, representing set B in a rectangle, we have it this way: B, this is the rectangle, then we have the element of B in the rectangle. So that is how to represent sets in a diagram. Now, before we dive deeper into the Venn diagram, let's look at the type of set that we have. Now, we have the finite set. This is the finite set. Now, what is a finite set? When we talk of finite set, it is a set that its last member, last element can be identified. So, for instance, we have set A, that is 1, 2, 3, 4, and then 5, right? So now, what is the last element in set A? The last element in set A is what? 5. It can be identified as what? 5. This is what we term as a finite set. Its last element or last member can be identified. Now, when we talk of the infinite set, that is the second type of set we have here. Infinite set. With this type of set, the last element or the last member cannot be identified. So we have it this way: B, 2, 4, 6, 8, 1, 2, 3. Okay, so these 3 dots indicate that the last element of this set is unknown. Okay, so when the last element is not identified, then that is what an infinite set. Now let's move on to the next type of set, that is the null set. The null set. When we talk of the null set, that is the empty set. A set with no element, a set with no member, right? So set A with no member. There's no member. That can be also represented as this. Okay, so this set, there's no element in the set. Now we move on to the unit set. When we talk of unit, it means 1. So a unit set is a set that has only one element, only one member. That is, let's say set B equals 2, or set A equals 1. You can see in there that there's only one element in the set. Set A has one element, which is set A has one element, which is what? 1. Then set B has one element, which is what? 2. That is what we term as the unit set. Now let's move on to subset. 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 When we talk of a subset, now, when there is a set with 8 elements, okay, and all 8 elements can be found in another set, that particular set becomes a subset of the other set. Okay, so what I mean is that if we have set A and then have set B, and then all the elements in set A can be found in set B, then A becomes a subset of set B. So this is what I mean. So let's say A, 1, 2, 3, 4, 5, and then we have B, that is 2, 4. Okay, now over here you can realize that this subset or the set B has 2 elements, which is 2 and 4, and these 2 elements can be found in the set A, that is 2 and then what? 4. So then B can be termed as what? A subset of A, because all elements in B can be found in what? Set A. All elements in B can be found in set A. Therefore, B is a subset of what? A. Now we move on to the universal set. The universal set. Now when we talk of the universal set, it is a set that contains all the elements under discussion. Okay, and it's also termed as the mother set. It is a set where all subsets are formed from. Okay, so we have a universal set and then we have subsets. All the elements in the subset are formed out of the universal set and can be found in the universal set. You get it? So that is what we term as the universal set. So if you have set A, even numbers, set B, odd numbers, it is the combination, okay, or the union of all these sets, including other sets, which could possibly be the complements of the set, okay, in the universal set. Now we move on to the equal set. The equal set. Equal is something is equal, they are same. Okay, so we have set A, let's say 2, 4, 6, and then we have set B, let's say 2, 4, 6. Right, so set A 2, 4, 6, and let's say set B 6, 4, 2. Okay. Now when you take set A and then set B, you can see that they are equal. The elements in set A are equal to the element in set B. Okay, irrespective of how it's been arranged in descending order or ascending order. You can see there is 2 in set A, there is 2 in set B. There's 4 in set A, there's 4 in set B, there's 6 in set B, and then there's 6 in set A, and then there's 6 in set what? B. This is what we term as what? Equal sets. They have equal elements. They have equal number of what? Elements and same elements. When we talk of the equivalent set, the equivalent set deals with the number of what? Elements in a set. So if set A has 3 elements and then set B has 3 elements, they are termed as the equivalent set, irrespective of the element. The element need not to be the same. They can be different elements. But if the number of elements in set A is the same as the number of elements in set B, they are termed as what? Equivalent set. So this we have here, let's say set A 1, 2, 3, 4, and then set B, that is, let's say 5, 6, 7, 8. Now you can see clearly here that the elements in set A are different from the elements in set B, but the number of elements in set A is the same number of elements in set B. Let's count. 1, 2, 3, 4. There are 4 elements in set A. Now set B, 1, 2, 3, 4. Set B also has 4 elements in it. So with this we say the sets are equivalent. These two sets are equivalent as compared to the equal set. Equal set must have same elements. Same elements. And then the equivalent set can have different elements but must have the same number of elements in there. Now we move on to the next. Let's move on to the next. Right, so we move on to the intersection of set. The intersection of set. The intersection of set. When we talk of the intersection of set, let's say we have two sets, set A and set B. Now the intersection of set is when there is an element in set A and that element also in set B. It joins the two sets. It brings the two sets into what? Contact. So for instance, we have set A and then set B. Let's say set A has 1, 2, 3, 4. And then set B has 2, 4, 6, 8. Okay. Now these two sets are intersecting because there are elements in set A that are also in set B, which are 2, 2, 4, 4, right? So the intersection of these two sets is what? 2 and then 4. Okay, this is what we term as intersection of sets. When there are elements in one set and the same elements are in the other set. Okay, the two sets intersect, right? So this is what we term as for the intersection of sets. Now when we talk of disjoint set, disjoint set. As the name implies, disjoint, they are not joined together. Okay, they are not joined. It means they have nothing to do with each other. Okay, they have nothing to do. So the element in one set totally differs from the element in the other set. Okay, they have nothing in common. So let's see, we have set A That is 2, 4, 6, 8, 10. And then we have set B. That is 1, 3, 5, 7, 9. Alright, so you can see why that these two sets have nothing in common. They have nothing to do with each other. Why? Because there are no elements in set A that are also in set B, and no elements in set B that are also in set what? A. So they are disjoint. Okay, they are not joined together. There's no element that will join these two sets together. That is what we term as well the disjoint set. And then we move on to the union set. This is my favorite aspect. Okay, this is my favorite aspect. The union set. The union set. And when we talk of union, what does it mean? When we talk of union, what does it mean? A mother, father come together, marry, they unite as one. Okay, they are both on their separate ways. They agree and then what? Unite. Okay, and become one family. Do you get it? So when we talk of the union set, is the bringing together of two or more sets as one. Okay, so this is it. So we have set A, 1, 3, 5, 7, 9. And then let's see set B, 2, 4, 6, 8, 10. Okay, so union, let's unite them, let's bring them together, let's marry them. Okay, we are going to marry these two sets. So we have set A, set B, so we marry them, A union B. This symbol is used to represent what? The union. So A union B, that is, we want to marry them, so we put them together, arrange in order of what? Magnitude, ascending, so from the lowest to the highest. 1, that is here, 2, 3, 4, 5, 6, 7, 8, 9, and then there we are, 10. We've united these two sets. We've married these two sets. This is what we term as what? The union of what? Two sets. You can also unite 3 sets, 4 sets, and thereof. But at the senior high level, you end up with the 3 sets. Alright, so that is how to unite sets. That is the union of what? Two sets. So in our next video, we are going to dive deeper into the Venn diagram. Thank you for watching. Share and subscribe.